Did you know that one of the most overlooked drivers of deforestation is right under our feet? Literally. It's in the soles of our shoes, our car tires, and so much more. Today, we're uncovering a major environmental issue hiding in plain sight: the massive deforestation caused by rubber plantations. What if I told you the amount of forest destruction for rubber has been underestimated by at least 2 or 3 times? Let's dive into the real story behind rubber and its hidden environmental cost. Today, I will explore a fascinating story published in Nature, which reveals that rubber plantations have caused far more deforestation than previously thought, particularly in Southeast Asia. This research is crucial for anyone concerned about environmental sustainability, biodiversity, and the future of our forests. In this video, I will walk you through the key findings, discuss the technologies used, and explain what this means for science, business, and the real world. This paper explores the environmental impact of rubber plantations on Southeast Asia's forests. It's well known that rubber is a major commodity, but what's not well known is how much forest is lost to make room for rubber. The authors of the study provide detailed maps of rubber-related deforestation, showing that previous estimates were significantly underestimated. Their goal? To push for better policies and stricter regulations on rubber plantations, which are often left out of deforestation conversation. One of the most shocking findings is that over 4 million hectares of forest have been cleared for rubber plantations since 1993 in the study area alone. 2 million of that has been since 2000. Their results are significantly higher than most existing figures used in global trade agreements. This suggests a vast underreporting of destruction. What does that mean for us? This means that rubber production is a more significant driver of deforestation than we realize, impacting climate change, biodiversity, and ecosystem services. This study uses advanced remote sensing technologies and artificial intelligence machine learning to identify rubber plantations. The researchers use Sentinel-2 imagery from the European Space Agency and the historical data from Landsat from NASA, combining the medium resolution 10-meter satellite data with advanced Earth observation techniques to create maps of rubber plantations and the forest they replaced. Using these technologies, they could distinguish rubber from other tree cover based on the unique characteristics like leaf fall and regrowth cycles, giving us the most accurate picture of the true scale of deforestation for rubber. These characteristics can be distinguished using the many spectral bands of Sentinel-2 and Landsat, not just the optical or visual RGB bands. To create the machine learning model, they labeled 3,826 reference sample points, about 2,000 for rubber, and a little less than 2,000 for evergreen forest. And then they trained a random forest model to identify rubber trees. This process of training a model on examples to predict other data is known as supervised machine learning. Supervised machine learning has gained a lot of popularity for its accuracy. In Earth observation, we have used machine learning since the 1970s, ever since Landsat 1. But back then, most were unsupervised machine learning, where the model puts imagery pixels into categories by similar values. Unsupervised machine learning is still commonly used today, especially in exploratory data analysis, because it's super fast and it does not require time-consuming labeled examples. Another critical finding from this study is that more than 1 million hectares of the rubber plantations are located in what's called key biodiversity areas. These are regions that are essential for the survival of many endangered species. Expanding rubber into these areas devastates local wildlife and plant species, further underscoring the need for more stringent conservation policies. While this study is a significant leap forward, there are some limitations. The focus was primarily on Southeast Asia, but rubber cultivation is also expanding rapidly in places like West and Central Africa, which were uncovered. One could likely extend their approach to other localities, even other types of vegetation for different applications through more training data. Also, the socioeconomic drivers behind rubber expansion weren't addressed in detail, even though they play a significant role in how land is both used and conserved. Obviously, deforestation from rubber plantations is not a black and white issue. In addition, to improve this research even more, businesses could extend their methods using the high spatial resolution imagery we now have available through commercial providers like Planet Labs, Airbus, Maxar. So going from this 10-meter spatial resolution that the researchers used to some of the 30-centimeter spatial resolutions now readily available would provide added details for monitoring. Finally, AI prediction methods like from LSTM models or even supervised models that make predictions based on other factors that we do have solid predictions for can give us a better idea of future trends. Their research pushes the boundaries of how we monitor commodity-driven deforestation. It shows that remote sensing and satellite imagery are not just tools for environmentalists, they are essential tools for creating accurate data to inform global policy. Using technologies like Google Earth Engine allows scientists to analyze, vast amount of data, giving us a clearer picture of how land use changes over time. I am most excited about this research that they use novel computing techniques to subset rubber plantations from other vegetation and then merge these results with other data through location. There are many straightforward ways to measure deforestation in general. In fact, the simple NDVI index has been widely applied since the 1970s to monitor vegetation health from satellites like the first Landsat-1 satellite. And now there are very accurate ways to measure deforestation from satellites. However, their accurate and comprehensive approach to distinguish rubber plantations allows them to merge this data with other data sets, using location to show deforestation directly attributable to rubber production. Businesses involved in rubber production are likely to face stricter regulation shortly. As countries and international bodies become more aware of the environmental impact of rubber, especially through studies like this one, there could be new diligence requirements demanding more sustainable practices and supply chain transparency. For companies, investing in sustainability isn't just a good PR move, it's quickly becoming necessary to comply with global standards. This study has real implications for policy and trade. With more explicit evidence on the scale of rubber-related deforestation, policymakers can better enforce deforestation-free regulations. The paper aims to ensure rubber production is included in global deforestation policies, like the European Union Deforestation Regulation. If you're inspired by the power of data and Earth observation to reveal hidden insights like deforestation, and you're wondering how your organization or business can leverage these methods, I'd love to help you implement similar solutions. Whether you're looking to monitor environmental impacts, improve supply chain transparency, or apply advanced AI and machine learning techniques to optimize your operations, I can guide you through every step of the process. I use similar techniques to those used in this research with Google Earth Engine to detect harmful marine algal blooms, oil spills, and illegal waste dumps. I've worked with leading organizations like the World Health Organization to predict disease outbreaks at a continental scale. I've also helped businesses like the National Bank of Kuwait and Bergan Bank train their staff on data analytics to drive smarter decisions. My expertise ranges from geospatial analysis and AI development to large-scale data management and visualization. I've built tools like the Ansela geoprocessing API that transforms industries by turning complex text data into actionable insights. If you want to advance your research, streamline business intelligence, or tackle complex challenges using state-of-the-art data science and AI, contact me directly through my website at scottpez.tech or email me at scottpez@brightworldlabs.com. Let's work together to make data work for you. As a final note on this article, the team that produced this fascinating research includes a very diverse set of researchers, both geographically, with affiliations in the UK, China, Switzerland, US, and Austria, and also with domains including ecology, geography, environmental sciences, and social sciences. The lead author and other authors are at the Royal Botanic Garden in Edinburgh, Scotland. This is a scientific center for the study of plants, their diversity and conservation, and it's also a popular tourist attraction. Other authors are at the Sichuan-Mana Tropical Botanical Garden. This is a similar institution in China. Other affiliations include the University of York, England, multiple research centers in Kunming, China, the University of Bern in Switzerland, the East-West Center Cooperative Research Group in Honolulu, Hawaii, US, Bangor University in Wales, and the International Institute for Applied Systems Analysis in Luxembourg, Austria. The diverse interdisciplinary background of the team surely contributed to its success. Thanks for watching. If you found this video informative, please like and subscribe for more content on how technology and science shape our planet's future and our public health. And let me know in the comments what you think about the rubber industry's impact on deforestation or how technology can help our world. Let's keep the conversation going.